Hello, today we're going to talk about topic 4, section 10, linear regression. So first you have your different types of data that you could have: ratio, interval, ordinal, nominal. And we've already talked about ratio and intervals and have done a Pearson correlation. So this section is all about ordinal. All right, that is your ranking. All right, so putting things in order and not necessarily knowing the how they vary, right? When you're talking about like taste and things like that, you're ranking it from best to worst. There isn't really like a jump, okay? So that's a Spearman's rank correlation. The next thing you'll learn is chi-squared, but for now we'll just focus on this. Okay, so here's the formula. Super fun when there's no repeated values. Okay, all right. Yeah, just kidding. You don't have to memorize that. Okay, you want to use it with your with your calculator. Okay, but it's just always good to see it and recognize it and know how to use it. All right. So for the first example, okay, so you have how the runners are ranked after 2 kilometers, and you want to see if that ranking changes much based at the end of the race. So this is what the actual results came to. So we get out our calculator, we go to Stat, Edit, and then we put in our data for List 1 and List 2. Okay, and then we can go to, let's see, Stat, go to Tests, and now we're going to go to Lin Reg T-Test. So List 1, List 2. Sorry, you want to make sure that you are, you type in your information correctly. So you have list 1, list 2, frequency, default is 1, and you want to make sure that they're not equal. Okay, we're not going to deal with the other ones, so not equal. So here, we calculate. You get this as your information. You want to see the rank coefficient. So just like with Pearson, okay, the Pearson correlation, everything is kind of similar in that sense. You scroll all the way down and you look at the R value. That's what you're looking at. So here, the Spearman's rank correlation is 0.679. Okay, so again, we used Lin Reg T-Test. All right, so let's do another example. So here you have your sets, and you want to put them in rankings and see how correlated they are. So you need to rank them. So let's see. This one would be ranked. Pressed the wrong button there. This would be 1. Let's see. The second ranking, that would be 2. These are tied between 3rd and 4th place, so you would average those. Then you have 5th place, 6th place. So here we have 1st place. Okay, 2nd, 3rd, and 4th are all averaged. So they get average of 3. And then you have, what is that? 4, 5, let's see. So that's going to be 5th, 6th. Okay, so now you just plug those into your calculator and use the Lin Reg T-Test. So here your answer would be, so your Spearman correlation would be approximately 0.585 to 3 sig figs. Didn't mean to cross everything out. Okay, so rank your data and then put it in your calculator, knock this out. Okay, so now we want to determine the significance of what the Spearman correlation coefficient is. Okay, it's very similar to the Pearson's correlation. Okay, you can describe it the same way as strong, moderate, weak, all of those things. Okay, so you again run the Lin Reg T-Test to get an exact p-value, and then you compare that to your level of significance, usually 0.05 or 0.01. So what I mean by that is, like, usually we say 5%. So if it's less than 5% chance of occurring, then that's really unlikely. Okay, it's not going to happen in the real world. But if it's more than 5%, then we say that it's likely to happen. That's usually the standard. always, of course, read the problems because they might say a 1% level of significance. All right. So for the data in example 1, we found the p-value and determined whether or not it has at least a 5% level of significance. Well, remember, this is what we found on our calculator. Okay, this is what it spat out. So since r is 0.85, well, think about what that means. Okay, our p-value, okay, is 0.22, all right, which is greater than 0.05, okay, which makes that correlation, okay, very likely. 22% chance of occurring, okay, so that's not significant. Okay, under 5% would be significant. That's what the level of significance means. So look at your p-value to compare it to your level of significance, kind of like your odds of it occurring. Okay, so here I didn't want to waste a whole nother slide. I want to make it all fit in, your pages for easy notes. So this is what you should know at the end. If you have any questions, please ask in class.